Everyone. Myself, Kandeli Sriharshini. I am third year undergraduate student of the Department of Mechanical Engineering. This is our group project based on tutorial sheet number 5 of the course Mechanism Sessional ME29002. Our group consists of B. Ambika, Satvik Navuri and myself. In this project, we need to select one question out of 5 questions in tutorial sheet number 5 and then synthesize and simulate the mechanism present in the question. We have selected the question number 1 from the tutorial sheet number 5. Firstly, shall we read the question, synthesize and make simulator for the windscreen wiper mechanism shown in tutorial sheet number 2, question number 6 with no quick return effect. In the simulation, mark the area wiped. Add any new idea you might have. In order to understand the mechanism that we are going to simulate, firstly, we need to know about the question number 6 in tutorial sheet number 2. This is the question number 6 from tutorial sheet number 2. For wiper mechanism shown, determine graphically and hatch the area wiped. Various dimensions related to the mechanism have been provided. This is the mechanism we are going to synthesize and simulate in our group project. The wiper mechanism may be considered here is the 4-bar mechanism. O2 and O4 have been grounded and hence O2-O4 is the ground link. O2A acts as coupler, O2A acts as crank and AB acts as coupler. O4B acts as output. The motion of wiper depends on the motion of the output. Now, let us know about this mechanism. The horizontal separation between two ground horizontal hinge O2 and O4 is 150 mm and vertical separation is 50 mm. The length of wiper is 200 mm. Earlier, we solved this question using graphical approach, but now let us understand this using analytical approach. In order to know the area swiped using the wiper, we should find the locus of point P, Q, R and S on wiper, and we need to find the variations of coordinates P, Q, R and S as crank O2A rotates about the origin O. Know the angle made by the crank O2A. So, we know the angle between O4B and O4C is 10 degrees. So finally, that only thing we need to find in order to know the coordinates P, Q, R and S is the angle made by O4C with the horizontal. Let us denote it with K. Our main aim is to find angle K. The angle made by O2O4 made by O2O4 with the horizontal is known to be tan inverse 1 by 3 from the geometry. So using all these details, we need to find the angle K. Now my friend Satvik will explain the remaining mechanism.
And now let's discuss about the synthesis of this mechanism. You can see this is the mechanism, and this is the simplified version of this mechanism, and you can see it's a 4-bar mechanism. In this figure we have to find the angle O4 O2A, and you can find this angle by the equation g of I equals to pi minus t of I plus tan inverse 1 by 3. You can see these angle t of I and this angle made up pi, and you can found this angle O4 O2A by the equation pi minus t of I plus tan inverse of 1 by 3. And in this figure we have to join O4A, and let's name it as F by from the triangle O4 O2A from using cosine rule. You can find the value of F by the equation F equals to root over c square plus d square minus 2 cd cos of g of I. As we found the value of F in the previous slide, You can also find the angles A of I and D of I respectively by using cosine rule. As you can see, angle A of I equals to cos inverse of A square plus F square minus B square by 2AF, and angle D of I equals to cos inverse of A square plus F square minus B square by 2AF from the triangles O4BA and O4O2A respectively. As you can see, the lines x and x dash are parallel. You can see these two angles are corresponding angles. As the corresponding angles are equal, you can see angle A of I, angle D of I, tan inverse 1 by 3, and angle E of I, they all sum up to form pi. You can find the angle E of I by using the equation E of I equals to pi minus A of I plus D of I plus tan inverse of 1 by 3. As we found the angle E of I, we know that angle K of I equals to E of I plus 10 degrees. We also found the K of I, and by using angle K of I, you can find also the P, Q, R, S, C coordinates respectively.
Hello everyone, I am B. Ambika. I am here to explain you the code which we have written to stimulate the windscreen wiper. The image displayed over here is the windscreen wiper. Let me execute the code first. This is how the windscreen wiper works. And now let me explain the code briefly. This is the code we have written, and A, B, C, D and all other are the variables which stores the length of the respective links, such as A is the crank length which is green over here, and B is the length of the coupler which is red over here, and C is the C is the length of the output link, and similarly D1, D2 and E are the necessary calculations needed, and these have been explained by my friends. Theta is the angle made by the crank which initiates from minus 120 degree to 240 degree and it sums up to 360 degree, and all TGF are the other calculations needed and necessary. This is the for loop which runs for 360 degree and which stores the instantaneous values of angles such as D, A, E and K. These are the angles, and it has been explained by my friends previously what they define. And these are the RS, UV, MN, OP are the coordinates of the area traced by the wiper. R is the x coordinates of the end point of the one side of the wiper, and similarly S is the R is the x coordinates and S is the y coordinates of the end point of the wiper, and similarly UV, MN and OP are the other coordinates. Here the section which defines the plotting and animation section, and we have given the title of this animation as windscreen wiper mechanism plotting. This is the XY coordinate, XY axis, and these are the tracing these are the RS, UV, these are the traced points of RS, UV, MN and OP, so on. These are the traces, and Cx is the array which stores the x coordinates of O2, A, B and O4 and also endpoint of wiper 1. Cy is the array which stores the y coordinates of O2, A, B, O4 and endpoint of wiper 1. Crank link is defined as the line which joins the origin and CX2 element and so on, and similarly coupler is the link which joins CX2 and CX3 element and so on, and similarly output link. And here the wiper links have been defined. Wiper 1 is the leftmost link which joins O6 and the horizontal beam over here of wiper, and similarly wiper 2 is the right link which joins O4 and horizontal beam of the wiper over here. And next we have defined the ground links such as O2, O4, O6 and so on. And before ending the for loop, we need to delete all the instantaneous values stored, because to start the stimulation from initial values at the next time, these are the initial values we have stored. Now let me show you how the wiper screen mechanism works. This is how the windscreen wiper works. The green link over here is the crank which rotates for 360 degree, and this is the coupler link which joins O2 link and the output link. And this is the output link which is yellow in color, and on which the windscreen wiper motion is dependent. And these are the areas traced by the wiper. Thank you.